All right, before we go into part three of brachiopods, you might be asking yourself, what is this? What is this guy's deal with brachiopods? Why? Why brachiopods? So here you go. Here's my origin story. Yeah, skip ahead a couple of minutes if you want. This is not going to be on the test. Yeah. So I grew up right about here in the Green Square, in this part in Ohio, and mostly I was growing up in the 1980s. Yeah. And what do you find in this part of Ohio? Well, you find brachiopod fossils or you find no fossils. Those are your two choices, so, deal with that. Yeah. And I have a couple of brachiopods in the collection that actually come from the town where I grew up, from Niles, Ohio. Yeah. Ooh. And then a little later, I think around 1988, went on a course over the summer, and they took us to right next to the federal detention farm at Milan, Michigan. It's not Milan, it's Milan. Yeah. And right next to that, you find stuff like this. And it is this gorgeous Devonian rock, and it's just full of fossils, solid. But if you look at those fossils, like, oh, I've seen that picture before somewhere. It's mostly brachiopods. So where I grew up, if you find fossils, they're mostly brachiopods. We went to this other place, which is like key in my development, all brachiopods, almost completely all brachiopods. A few other things, but honestly, they're just so wonderful. Look at them. Yeah. Then I went on and I did a faculty appointment in Britain, '07 to 16, where I got to be the fossil curator for a little museum of zoology. There's our elephant, which some old dude shot, and then actually no, there's another head of an elephant that somebody shot and mounted on his wall. And when he died, his wife did not want that in the house anymore, and so she donated it to the museum. This one, if you look really closely, there are little. It looks a little green on the tips. This was a circus elephant, and it had little bronze or copper caps on its horns. Yeah, I guess somebody decorated it up all fancy. But yeah, once it died, it got donated to the museum, so that's kind of cool. Yeah, neat. But there we had a lot of problems because all the records have been lost for most of the fossils. And so we would try to go through and say, okay, can we figure out what this is? It's probably something from the UK, which they mostly were. And a lot of those, a lot of those were brachiopods. And so, yeah, it's like, life keeps throwing you brachiopods. You might as well deal with them. From there, I went to Texarkana. This is Texas A&M, Texarkana. Bet you didn't know there was one of those, huh? And we got a nice little lake, and my building was this one. My office was right over here in the corner, right here at the end. It was a very pretty office. And yeah, when I started, there were two buildings, three if you count the residence hall, which is over here. Yeah, and now there are like five buildings, so that's progress for you. And then when we came to Texas, I wanted to be able to teach, and I no longer had a museum's worth of fossils at my fingertips. And so it's like, well, I gotta go get a whole bunch of fossils fast so that I can teach a fossil course because fossils are fun. And so we started going out, in particular to Jacksboro. And I don't know if you can see him, but there, there, brachiopods. So many brachiopods. Little bits of mollusks, little bits of a cephalopod shell, nautiloid. But just tons and tons of brachiopods at this very picturesque site. This is the Jacksboro limestone around a little lake. Yeah. So, yeah, it's been brachiopods. It's always been brachiopods. Whatever. Yeah. And they're fantastic. They are a much more complete part of the fossil record. You have a lot more examples anyway. I guess it's not necessarily more complete, but they lived in the water, often in places where rocks were forming. And so you have a much better fossil record, or at least a richer fossil record of brachiopods than just about anything else. Yeah, which is why some people don't like them, but it's why I love them. Yeah, because they're everywhere. Here are some living brachiopods. This is a sponge up here, I think. But these red guys, those are a brachiopod. These little orange ones, those are a different kind of brachiopod. And these are both in the Terebrachulid branch of brachiopods. So yeah, look at them. Still doing well. Isn't that nice to see? I think so. Yeah. Okay. Here are brachio babies. So let's see if we can get this to run. And Nope, looks like it's not going to run. Oh no, it's going to run just slowly. All right. So there we go. So here is a young brachiopod. And at this state, the shell is still mostly just the chitin. It hasn't really developed yet. But you can see the actual creature is right here in the center. So there's our brachiopod, and here's our brachiopod. These guys are a little older on this side, and they have grown their tentacles. So they did that metamorphosis, and they turned that little lump into a whole bunch of tentacles. And when they're ready to feed, they stick the tentacles, in this case, out of the shell, or in other cases, they'll just open the shell and let water into the tentacles. A lot of the other kinds of brachiopods are maybe more frightened. They're like little shut-ins. They stay inside there. They stay in their box, yeah, forever. As they are generating the current to feed, they will also end up moving along. And so the early stages are planktonic. They can float around in the water column. And then eventually they will pick somewhere, they will settle, and at that point they will grow their little pedicle out the back, and they'll use that as like a little digging arm to help anchor them into the substrate or attach them down to the substrate. And so here you can see it in different kinds of lighting. This is extended, this is closed. And with this sort of polarized light, you can see the extra little sensory hairs. These are the little setae that it has on the edge. And those are going to be its main sort of sensory organ. They can sort of taste, I think, what's going on around it, at least possibly, but they would also be very vibration sensitive, so it could tell if something is brushing up against it, and then it could snap shut and try and keep the animal alive. Yeah, so there you go. Brachiopods, adorable. The Paleozoic brachiopods, the old brachiopods, generally live this kind of upside down lifestyle. Looks upside down because if you just have it in your hand, you're going to naturally want to flip it over. This is the dorsal valve on top. This is the ventral valve on the bottom. The ventral valve is usually going to be convex. Dorsal valve will often be concave, depends on which kind of brachiopod you're dealing with. Here's the posterior. There's the little hinge where those two come together. And this kind actually grows little spines out from the hinge line, which are going to help to anchor it in the sediment and keep it from getting flipped over. So, yeah. Here's a modern brachiopod, and we're illustrating water flow. So water is going to come in the center. It's going to be pulled in right in between. Here are the feeding arms. Here are the feeding arms up here. And it's going to then be pushed out of the feeding arms. Think of it as like breathing in your nose and then breathing out your mouth. We're redirecting the flow. So they're breathing in the center and breathing out the sides, but they're doing both at the same time. It's just opening up for water flow, both in and out. And they're going to try to capture all of the little single-celled organisms they can in that time. So yeah, they're going to eat whatever they can catch. All right, a couple more brachiopods, soothing brachiopods. Look at them here. There's that nice red one, that's the Caloria. And here's this nice little orange one, I forget what it's called. All right, there are lots of features on a brachiopod valve, but most of the ones that are useful for taxonomy are going to be found on the insides. Usually when you find brachiopods, you will only see the outsides. And so you either have to dissect them and get rid of one of the valves to try and open them, because you can never open them. Or you'll have to get really lucky and just find one that has come apart and not been destroyed, because when these things come apart, they are very fragile and they get destroyed easily by human hands, even easier by ancient currents. But on the inside, you can start to see things. So you can see the muscle attachment scars. So here they are, and so here's a bigger version of that shown in green. Nice little muscle attachment scar. Here's our little hollow spines along the top. Here's our little cover for the hinge. And there are different names for each of these things. So let's look at the median septum. It's the little bar that runs down the middle, and sometimes it's very long, and sometimes it's very short. So look over here and see if you can tell which of these, because these are all pretty closely related, but some of these have a long median septum and some have a short one. Can you spot the long ones? Did you say D? Wow, that's really long. Look at that. It goes from there all the way down to there. So posterior almost to the anterior. Here's another one, this imprimaria. Yeah, it goes at least to halfway before it fades out. Then you got Sulcateria here, and if it has one, it's very short. It only comes to about here, but it's in the shadow there. Same thing with this Lysoconides, very short one. And these are all at the same stage of growth. These are like maximum size adults. So this is an actual difference in how it was set up on the inside. There are not many features on the ventral valve that are actually going to be useful for taxonomy. But teeth are going to be another one. Like, look at these great big chunky fang teeth. Look at these little polite sort of squares up here. Look at these little rounded things. Those are complete and intact. And these have big fat sort of peg teeth, which are the hinge teeth that are going to go into a socket on the other valve, on the dorsal valve. Yeah. So when you are writing a brachiopod description, you're going to go down this list, generally from posterior to anterior, and you're going to describe each of the features that you see all along the way. Yeah, that's how you're going to do it. Here are some of the spines on brachiopods, and as you can see, usually they break off, either during fossilization or collection. They get broken, but when you get them and they're actually still intact, the spines were connected to the inside, at least at the growing edge, and then sometimes they would close off the spine with later growth. But they're going to reach out, and they use them to hold on to things. It's like, yeah, look at these little spines reaching up here, like, nope, I'm going to hold on to you. Yeah, hold on for dear life. And it's going to be productids that are good at this. That's what their little productid spines are for, and that's why we like productids so much. They're just gorgeous. And genetically, it's programmed to just grow the spines. And if they can reach out and touch something, then they will reach out and they will mineralize up fairly quickly, probably, and hold on to that thing forever. They'll just make a little rigid support onto that. If they don't really go anywhere, they'll just sort of point toward the anterior, kind of searching for something. If they don't find it, that's all right. You've still made kind of a comb structure that'll help to hold the brachiopod in the soil and keep it from getting flipped over. Inside a brachiopod, let's say we slice these bad boys open. Look, you can see there's a difference where the muscles attach. So there's a point where the muscles attach on the top, and the muscles connect down to two little points here. And if you zoom in on those, let's see them. There we go. Yeah, you can see there. You've got a different texture of shell, which has been built up underneath the muscle. And so there's kind of a different process for building up underneath tissue which remains attached all the time compared to this sort of the normal shell. And you can see it doesn't have the little columns and pillars anymore, but it has little sort of white columns. And it grows the rest of the shell in layers. So kind of related to the old brachiopods. Here's a different one, and you can see there's the muscle attachment scars in the top, and here they are on the bottom. Yeah. And so you can find those by slicing the brachiopod open. Now there's two sets of muscles in a brachiopod. Much easier than human AMP. I don't even know how many muscles we have, but I hear it's a lot. Yeah. So, yeah, here's brachiopod A and P. You got your adductors that close, and you got your diductors that open. Adductors, diductor, adductor, diductor. Yeah. How do those work? Both the muscles just contract. That's the only thing muscles know how to do. But the adductors are attached from one shell to the other. So these are attached to the brachial valve and attached to the pedicle valve. And so those are going to, when they contract, they're going to snap the shell closed, just like that. The other ones are going to be attached to only the ventral valve. So the ventral valve is on the bottom, also called the pedicle valve. And they're going to be just holding on to the tip of the dorsal valve. So they're going to go from the ventral valve over here, and they're going to pull down. When they contract, they're going to lift up the top valve, the dorsal valve. And so that's how they open. They contract their diductors, which are hooked into two little grooves right here on the very tip of the dorsal valve. That's kind of the way you have those garbage cans where you step on the pedal and it pulls on one edge and it opens up the lid. Yeah, it's kind of like that. So that's brachiopod muscles. That's how they work. Yeah, and they leave marks on the shells. Here are some of those teeth, and you can see the big sort of square teeth. Look at those lovely square teeth. You can see these smaller, kind of rounded, really short teeth. They're barely even there, super delicate. And you can see these big, fat, chunky, sort of peg teeth on this other group. And yeah, so the teeth are one way you can tell these outwardly very similar brachiopods apart from each other. Now, the real stuff, the real deal is on the dorsal valve. And the dorsal interiors for brachiopods are magnificent. Here, let's blow that up a little bit. So you've got imprints of the digestive tract, potentially, or possibly there are reproductive organs there. Unless you find one with soft tissue preservation, you probably can't tell. You've got sort of water flow control devices. You'll have trenches, so the water's going to come in at the center and be pushed out over the feeding lophophores, which are going to be here. So it's going to in the center and then squish to the side, spread out over these tentacles, and then pushed out. Here's the little groove where it's going to get pushed out. And you got a little wall here at the back to kind of deflect it. But look how different these things are inside. If you saw the outsides of these shells, they are the same shell, very nearly. You would have a hard time telling them apart. Yeah, this is how you can tell them apart, tell one from another. So let's look for the median septum. There's a median septum on either valve. So we're looking at the ventral median septum before. Let's look at the dorsal median septum. Some of these have a long median septum. Some have a very short median septum. Can you spot them? I'll give you a moment. All right, did you spot the longest median septum of them all? D, right? Look at that median septum. Boom, look at that. And here we've color-coded all these things here, and then this is a drawing of the inside of one of them. So you can see which parts you're supposed to be looking for. This one actually has a very long median septum. It goes along here. It's very low to the floor, and then this is part of the median septum, this giant spike at the end of it. Like, that's weird. That's a difference, yeah. Look at this one. It's very short. It's barely to halfway. It's tiny. It's kind of anemic and small and weak and delicate and fragile, and you just want to cuddle it or something. And this one, it starts late. It ends early. It is the worst worker in your office. That's Seductaria placida, yeah. And it's got two little knobbles out here to kind of deflect water flow to get it a little bit turbid, we think, on its way in. So, yeah. Brachiopods. Those are some of the parts. This is some of what we're going to do in class. We'll give you some brachiopod valves or images of brachiopod valves, and let's see if we can build a description of these things. So, here's some more little brachiopods stuck down to a rock. This is a different kind, Hemithyrus. There are many brachiopod names, and here are some. And these things are very widely misused, usually because the original descriptions were very vague or broad or are in desperate need of being replaced. So there are a lot of things in the world called lingula, and they span hundreds of millions of years, and they're probably not all lingula if you were able to get their genes, which we probably can't get. But also, if you look really closely, there are big enough differences that probably we can split this up into smaller groups that are a little more precise and show the change over time. Yeah, because that's the point of naming things. Here are some craniids. Look at them all. Look at all the little craniids. So some of these are dead. They've lost their top valve, but a whole bunch of them still have it there. These are the ones, remember, that are like Oscar the Grouch. They just lift up their lid when they want to feed and they snap it back down again. And they kind of look like a little face. These are little upside down faces. There would be the eyes. There would be the little nose in the center. Yeah, craniids. Popular then, popular now. Still going fairly strong. There's a lot of them around. They're not particularly uncommon, but you will probably never see them because they are so well hidden. And hey, yeah. Ultimate hide-and-seek champs, the craniids. Why not? There's Novocrania. Yeah. Okay, so let's unpack some of that stuff. What's a brachiopod? Basically got a little worm with two large feeding arms. They're called the lophophore and those are going to generate water current. They have little cilia that spin, and they're going to, it's the cilia on these that spin. The tentacles just inflate and then deflate. And they're going to catch food, and they're going to pass the food along to the mouth, which is going to be located in the center where those two tentacles meet. What do we call the valves? The ventral and dorsal valve. How do you recognize them? The ventral valve is usually going to have a hole for the pedicle, at least at some stage of its development. And the ventral valve is usually going to be bigger, and it's going to be found on the bottom generally when these things are living. How do if you look at the inside of them, they're totally different. The dorsal valve is going to have the imprints of the feeding arms. That's why it was called the brachial valve. The brachia means arms. And the ventral valve just has imprints of those muscles that are used to both open and shut the shell. So there's relatively little going on the ventral valve interior. How do the muscles function? You got your adductors and your diductors. And the diductors aren't like pushing something open. They're reaching around and pulling down on a little hinge, just on the tip of it. It's like trying to open a door by grabbing it right along where the hinges are and just sort of applying a ton of force to just barely make it open. Really slow, really inefficient, but it works for brachiopods. So they have a hard time probably opening relative to shutting. And if you're thinking in terms of risk reward, you want to be able to snap shut in a hurry when the first sign of danger is there. All right. How do the body parts leave an impression on the shell? Well, the shell is built up over time, and the parts are sitting on it. And so it will build up around the parts. You know, little channels where water used to go or where body parts used to sit. And those are very useful for telling different kinds of brachiopods apart, if you can see the inside of your brachiopod. If you can't, you're in trouble. You are in trouble. How do the muscles function to open and close the valves? We already did that. Let's see. Read a map of brachiopod internal features. So that's the thing we're going to do in class. We're going to have those maps. Hand those out, and we're going to see if we can write a description for a brachiopod with all the parts. See if you can find them. And there'll be a couple kinds of brachiopods there, maybe, and see if we can distinguish those from each other. See what grounds we have to distinguish them. All right. Which groups of brachiopods still exist? Rhynchonellids still exist. Pterobrachiopods still exist. Craniids still exist. Lingulids still exist. That's pretty much it. Yeah, there's subdivisions of some of those, but yeah, that's the big four. What are the characteristics of members of the Lingulata? Those have the calcium phosphate shell. They are inarticulate, so they can go side to side in addition to opening. They have a big old pedicle coming out of at least lingula. Really cool. And the pedicle comes out between the shells. It doesn't come out from a hole in either shell. Craniates don't have a pedicle at all. They cement one shell down to something, a rock, another brachiopod, whatever, and they'll then lift up the other shell. They have opening muscles that will lift this up, and they will feed that way. And Rhynchonellata are going to be all the rest of the brachiopods. They're going to have a calcium carbonate shell like craniates, and they're going to have a hinge, and the hinge is going to have little teeth. So it's a hinge more like that. The teeth will go down into sockets so they can only open straight up and down. It cannot rotate side to side. It would break its little teeth off. Okay. Describe brachiopod development. That's what ontogeny means, and how it's reflected in the hard parts. So the early stages where it sort of goes from this to this and starts to make its shell, those don't fossilize. And so those are going to be missing from the fossil record. But from the earliest shell, you can often see that as like a little disc at the very posterior tip of a brachiopod that has grown. And so, the brachiopod preserves all of its little life stages of growth at different points in its shell, from posterior to anterior. Myquetia is one of those things with the little layers and then pillars separating the layers in the shell. So it's one of these early possible brachiopod ancestors, maybe like a crown group from which brachiopods emerge, or a sister group to brachiopods from very early on. So yeah, it's got two shells. The shells have that similar construction, layers and pillars, with little holes coming out like brachiopod spines sometimes are. And it's thought to be a sessile filter feeder, just like brachiopods. I mean, there's a lot of sessile filter feeders in the world, things that just sit still and pull water toward them, because it's a lot easier than running around and catching things yourself. And then identify typical examples of the main brachiopod groups, things like craniids, lingulids, rhynchonellids, strophominids, productids, orthids, terebratulids, atripids. Yeah. I don't know. There's a couple more in there, but yeah. See if you can identify those. And we'll put some of those on the spots test, and we'll practice a lot of those because practice makes perfect. Yeah. So thank you very much. And spiriferids. We can't forget spirifers. They're the best. Yeah. Thank you very much. This has been Brachiopods in Depth. We got a little more brachiopod content coming, but this is most of it.